Holmes is very interested in all aspects of university education. In 2012, she was named a Stanford University Fellow in undergraduate education. Please join me in welcoming Professor Holmes.
Thank you very much. I'm very happy to be here. I teach a course on breaking codes and finding patterns, and I find it very helpful to think about what people did during the war and even before when I think about my own work. And so in some sense I'm what I call a data listener, and I want to let you participate a little bit in what it is like to look for patterns in data. We'll take a little historical viewpoint, but to start with I hope that everybody has a handout. And if you don't, there are handouts on the side. It's quite important you have a handout so that you can not follow along. The handout was carefully typeset from another era, so that you get the complete feel. So I'm going to start in this code breaking with what's called a substitution cipher. And maybe some of you who are sitting here for longer than others have already broken this. But this is the cipher which is the first cipher on your handout. And when I ask you how can you possibly break such a cipher, if you know how many possible substitutions there are 26 factorial, it's a very large number, you think it's impossible. But the first thing you might do would be to do the frequency of the different letters. And so if I looked at the frequencies on the ciphers, what do we have here? Well, there's a large bar at W, so probably W is the letter. Right, so you're with me, that's good. I actually ordered them down here so that you can rank them from the most frequent in the code to the least frequent, so in the ciphertext. And the second one is G, and then we have E, K, O, U. Well, I don't know all the letters rank in frequency off by heart, so what I do in that case is I get a little bit more data, so I'm going to look at a text from Moby Dick. And I didn't take the whole of Moby Dick, I just took about 1,600 characters, and I'm looking at their frequency. And so that gives me an idea of what the frequency in English looks like. And so here we have the letter E, in fact, is much more frequent than any of the others, and the second one's probably the letter T. And if I order them, you'll see how they order down. So you can see that by pairing, in some sense, the frequency in the code with the frequency in English, and here I've done it left and right, we could go down and we could help ourselves and actually break the substitution code. The advantage of doing that is that we have quite a lot of signal in the frequencies of the different letters, and so it's possible to do. And in fact, if you start replacing the letters, the E, the T, and so on, you come to a point where you can read the text. So it says, in a medium saucepan, bring the milk and cream to just below a boil over medium-high heat. Okay? Probably some of you who know me have some prior information on what the recipe is. And if I take the whole recipe, it's a recipe for creme caramel, and a medium saucepan, bring the milk and cream to just below a boil over medium-high heat. Meanwhile, mix together the egg yolks and so on. In code breaking, there's a big advantage over statistics. The proof of the pudding is in the eating. That is, you can see whether you succeeded in breaking the code practically immediately when you see the text. And here is the ciphering, what I call the permutation, the ciphering permutation. And this is what we call, and we will call, a monoalphabetic substitution code. There are lots of them. There are almost more than 10 to the 26 different codes and that you could do in this way. And this was already used in the 9th and 10th century, and they were broken at that time already. So the diplomats later decided around 1550 already that this wasn't an acceptable code, and they needed a code in which you could change the substitutions. So they invented a method, this is a device actually with a ring, where as you go along it, you're going to take a different substitution code, and this is a device from De La Porta, and this code was called the divisionnaire code because it was written up by divisionnaire, and in French they called it the chiffre indéchiffrable because it wasn't broken for almost 3 centuries. So it's a very, very hard code to break. Let me tell you a little bit more about how you would encipher something. So if I take the text in English here,